Hello and welcome to this lecture series of Deep Learning Part 2. In last lecture, we understood concept of deep learning and artificial neural network. In this lecture, we will understand forward propagation. I advise you to go through the previous lecture if you wish to get fundamental idea about deep learning. So, here in this particular lecture, we will understand about forward propagation. In this lecture, we will implement forward propagation using Python. Let us recap what we saw in our last video lecture. As we discussed, the artificial neural network is having three layers. The first layer is input layer, the second one is hidden layer, and third is output layer. We understood how to calculate weighted sum Z for neural network using input, weights and bias. To understand this, how it works, let us take an example and work on this. To understand forward propagation, we will take simple and small neural network. Consider our neural network is having one input layer, one hidden layer and one output layer. For simple understanding, we have two nodes in input layer x1 and x2. Weight w1, w3 from x1 and w2, w4 from x2 having bias b1 and b2 for hidden layer weighted sum nodes z11 and z12 respectively. The hidden layer is having two nodes which are weighted sum nodes Z11 and Z12. We will obtain activation node A11 and A12 from the weighted sum nodes Z11 and Z12 respectively. Finally, we have one input layer having one output node Z2. We will understand forward propagation and also understand how to obtain the output and also understand how to obtain the output from this neural network. We will code this using Python. Okay, so we will write code here and understand it in three steps. The first step is consider input layer and the hidden layer. We will find the weighted sum for the hidden layer in our first step, and then using the weighted sum Z11 and Z12, we will find activation node A11 and A12. First of all, as you see, we are using 6 weights and 3 bias for this neural network. For this example, we will generate weights and biases randomly. In code line, if you look at the code line, the line number 2, we are generating random values for 6 weights, and in line 3, we are producing set of random values for 3 biases. As shown in line 5, we will display this randomly generated values. We can see the output which shows the randomly generated values for weights and biases. Now, we will use these values to obtain weighted sum Z11 and Z12. Now, let us consider our input node values x1 and x2 as 0.5 and 0.85 respectively. We will use these values x1 and x2 to calculate the weighted sum Z11 and Z12 of hidden layer in this particular example. As you see the code, line number 6 and 7 initialize the values of x1 and x2, and using print command in line 8 we are displaying it. Now let us calculate the weighted sum Z11 first. As we know, the weighted sum is equal to sum of product of input value and its corresponding weighted values plus the bias value. As you can see in line 9 of the code, we calculate Z11 as product sum of both inputs with their corresponding weights and then adding bias value for that node. As shown in line 10 of code, we display the value of weighted sum Z11. Similarly, we calculate weighted sum Z12 as shown in code line 11 and display its output in line number 12. Okay, now we will calculate activation node A11 and A12 from the weighted sum of the inputs using the sigmoid function. As you know, sigmoid function is inverse of sum of 1 plus exponential of minus z, where z is weighted sum. We use sigmoid function to obtain the activation node value in process to keep the value in range of 0 and 1. Here, we calculate A11 and A12 as shown in line 13 and line 14 of the code, and as output, you can observe the obtained activation value for both the nodes. Now, as we have obtained the activation nodes, these activation nodes will be used as input node for the next layer. In our case, A11 and A12 will act as input node to obtain weighted sum Z2 for the output layer. Our weighted values are W5 and W6 and bias is B2. As we can see in the code line number 12, we calculate the weighted sum Z2. Here, A11 and A12 are acting as input nodes B2 as bias. As you see, the output shows the weighted sum of hidden layer activation node to output layer. We obtain the value as 1.725. Now, next step is to obtain the activation value A2 from the weighted sum value Z2. Here, as step 3, finally, we obtain output value of the neural network using sigmoid function. We obtain this activation value A2 in line 19. We calculate value of A2 from Z2 using the sigmoid function and finally we display it. Hence, the output we obtain for the neural network for the input value x1 equal to 0.5 and x2 equal to 0.85 as 0.8488. Hope you understand the process of obtaining output from the output layer using input layer, where we feed the input values and using one or more than one hidden layers. This process starts from input and proceeds towards output. This process is called forward propagation method. I wish that you go through the code again and you can pause the video and you can execute the codes as well. Of course, when the neural network is having multiple nodes in input layers and multiple hidden layers are available, it is not proper to use the methodology what we obtained in previous example. Because if we keep calculating node by node, the coding part will be too lengthy. See the figure shown in this particular slide. It shows n nodes in input layer and m nodes in hidden layers. It is generalized form of the neural network. We can use generalized form to calculate for any number of input nodes and any number of hidden layers of different nodes. We will go through this generalized example of calculating output from n input nodes and m nodes available in hidden layers in coming example. So in part 3, we will go for generalized concept, generalized coding for n number of nodes in input layer and m number of hidden layer nodes. So that will become the generalized form. I hope you like this lecture. If you like it, just subscribe the channel and you can always give your thumb. Thank you very much for being with me. I hope you will go through the code again and execute at your own using Python. Thank you very much.